Let's look at a more complete example. I have a function called absdiff, which takes an x and a y. If x is greater than y, then we set result to be the subtraction, otherwise we subtract the other way around. So the absolute value of the difference. And here is the machine code implementation of this. So we have a comparison on RSI and RDI. So RDI corresponds to x and RSI corresponds to y. And then if x is less than y, we jump down to the then branch here. So we jump to hex address C, and that does a move of RSI, that is y into EAX, or RAX rather, since these are longs. And then we subtract, so that is y minus x, just like we have in the then branch over here. And then we turn. Otherwise, we subtract the other way around. And you'll notice that instead of doing another jump to join together to the return result here, the compiler is likely to just return from the whole function, since after it sets EAX, that is the result it wants, and it just returns. We can look at that in GCC's output, so I've got that same absdiff function. I can say GCC. Let's look at the assembly code that GCC generates. So if we look at absdiff, we see, again, a lot more metadata than we usually have. And what you'll also see is that when we have the jump here, it says .l2, where L2 is the label. So in my picture, before on the slide, I had an actual address, hex C, but in the assembly code, it instead makes a label. It abstracts over this. So that's the little bit of work that assembler does. It picks addresses and relative addresses to make things like this work out. Otherwise, the code is the same. If we compile it all the way to an object file and use objdump on the object file, we should see something very similar. This time, it really does say jump to hex address C, but also the linker may move this function around, and so it reminds us in the disassembly that really what it says in the metadata of this object file is that I mean the start of the absdiff function plus hexadecimal 12. Right? In any case, when you go down there, you see the move instructions and the subtract instructions that you expected to see in the else branch. So again, that was the way we might write it if we're writing assembly directly, or if the compiler is generating the assembly for us, whereas this is more the disassembled machine code view of things.